Hello, my name is Emily Gustosi. My project is on predicting coral bleaching for ITCS 5156, spring 2024. I chose this topic first because coral is really special to my family. We're scuba divers and we've been diving around the world. It's also a very timely topic. Right as I'm finishing this presentation, the fourth global bleaching event in human recorded history has started. Reefs provide important habitats for animals and barriers to protect our coasts. We need to help them survive in changing ocean conditions, and in order to do so, funding needs to be prioritized to appropriate areas for research and conservation. In case you're wondering what coral bleaching is, healthy coral has a symbiotic relationship with algae, which provide the coral with nutrients. These algae are what is colorful. When ocean conditions become stressful, for instance, when temperature and pH rises, the algae leave the white coral behind. Before we can make any predictive models, we have to have some data about where the coral is bleaching and under what conditions. The oceans are really big though. Some data comes from satellites, others from automated and manual underwater images. All of that is combined with water and surface condition data, also gathered in many different ways depending on the data set. The main paper I chose uses a data set that uses bleaching percentages based on underwater observations and images. That led me to look more into what it takes to collect underwater coral images. Some challenges to processing underwater images are pointier than others. Fawad, Ahmad, Ula, and Choi created a customized bag of features framework to address many of the same issues other visual projects run into: variations in illumination, orientation, scale, and view angle. I thought it was interesting how the bag of features model can be used to process images, just the way the bag of words that inspired it can be used to process language. Their model performed really well. Here's an example of its output. I looked at another related work that is very similar to the one I ultimately chose. It focused on making predictions. Boonham's article is focused on predicting coral damage using a data set from seas around Thailand. We are very clear about how they trained, tested, clustered, and evaluated their models from the way that they presented it in the article. At the end of the article, they propose a model based on SVM with 6 coral damage levels based on the results of k-means clustering results. The paper I ended up choosing to reproduce also focuses on creating models predicting bleaching based on environmental conditions. I chose it because I appreciated how Mataretti, Bosch, and McCalla clearly explained how they performed their data cleaning and feature selection. An interesting feature of this study was that rather than Having one or few models to test, they used a Python module called Lazy Predict to select one that they then further tuned using Grid Search CV. Their article aims to create a model to predict average coral bleaching at specific locations given specific conditions. They created a Python app that can be found on GitHub, though it takes a little bit of debugging to get it to run. The dataset starts with 47 features. The techniques used to reduce the number are ones we used in class. The real work, though, starts with plotting the Pearson correlation coefficient after the features have been reduced to the numeric features. The authors used this analysis to remove coefficients in order to prevent multicollinearity. I ended up using it to keep tripping myself up as the first place in my work where something visually went very, very wrong for the first part of the project. I eventually realized I was using the 2022 version of the dataset instead of the 2019 version of the dataset, and it made a very, very big difference to everything. So, after what should have been a rather easy start to the project, I finally was able to get to the features most closely correlated to bleaching, and being able to create this was just so, so satisfying. And seeing my work on the left looking so close to the article on the right, I, yes, a very good day. But it was not meant to last. From there, the article goes on to use Lazy Predict to choose a model and then tune the hyperparameters. As you can see, my results are in a very different order. One difference I know right off the bat is that my Python module versions are already just different from what the um, authors were probably using, but I'm not entirely sure what they were using. And even when I do use the random forest regressor, I'm not getting the same performance that they did. So I'm probably going to be playing detective with this right up until the last second I can spare. This mystery has me hooked. Thanks for listening, and I'm looking forward to watching your presentations.